Hi, Jessica.
Hi, Christian.
Um, Today we consider that people who buy our robot are today early adopter, but Jessica was our first customer, so we are very happy and proud to have you as a very, very, very early adopter. So as you bought the robot last year, and so we deliver it at Christmas time period.
Very nice gift. Thank you again.
So thank you very much, Jessica, for your trust. And we just have a few questions for you. Could you briefly introduce the course in which you use Emio?
Mhm. I used Emio in the Introduction to Continuum Robotics course that I'm teaching here at the University of Toronto. It's an 11-week course, 2-hour lecture and 2-hour practicals each week. And it's a mix of, I guess, traditional lectures and also paper discussions. So it's more an experiential learning course. And in the practicals, we used Emio to give the students an opportunity to work on an actual robot, because in previous offerings, we were mostly working in simulation.
Okay, great. So what are the level of the students? The,
Undergraduate students,
okay.
it's offered in fourth year computer science, but also open to graduate students, so master students or PhD students in their first year of study. So in the cohort we were introducing EMU, we had 20 students in total, and I think only two of them were actually graduate students, so master students. All the others were undergraduate students in their fourth year.
And so what are your main objectives, learning objective when you introduce Emio in the class?
Yeah, that was actually great because Emio kind of addresses most of the course learning objectives that I can tell you about. So one of the learning objectives is that students are able to identify continuum robots and differentiate them from, I guess, conventional robots and from hyper-redundant robots. Another learning objective is to understand continuum robot capabilities and their degrees of freedom. So that's an interesting discussion we had with Emio. Also, they should be able to describe a continuous shape of a continuum robot using curves and differential geometry. So that obviously ties in very nicely with Emio and the whole simulation behind it. They also have to derive and implement kinematics and kinetostatic models, where Emio is also supporting that really well. We also discuss motion planning and motion planning challenges in contact-rich environments where the pick and place task directly ties into, and then they also need to understand and implement open loop and closed loop control strategies,
Okay.
ties in perfectly with the lab, and then explain modeling and control challenges, which we could also explore with MEO. And so that was great to see that all the learning objectives that I had anyway, MEO is directly connecting to all of them.
You basically tested quasi all the different labs we propose, or you did select some of them? Yeah.
Yeah, we had to make a selection. I guess
Yeah.
as early adopters, that was clear. You had a very a nice set of labs in the beginning, but we ended up only using the pick and place task programming because that was easily accessible for our students. And then we adapted the control lab a little bit so that they could compare open and closed loop performance, did some PI gain tuning, and we also ended up using the custom designing of the legs and see how that changes the behavior of the robot. That was also something we ended up using, but we had to make some adaptations.
Great. And was it easy to integrate MU in your teaching activities?
In general, I would say yes, because I think the software design is really easy to make changes. I loved that it was all the markdown files that you could easily customize. That was very accessible to us as computer scientists. The simulator is fast and is really accurate and really nice to see. That is very important. What I really liked is that the whole pre-programming of tasks is somewhat similar to what the students are used to from their introduction to robotics course, where they use Franka, Emika Panda robots. And so this whole, like, I guess, task drag and drop, that was something that the students knew. So it was very easy for them to pick it up quickly for the pick and place task, for example. That was really easy, but I guess, well, there's always challenges as your first adopter. I think most of the labs that existed when you shipped the first version of Emio were designed with engineering graduate students in mind. And so I faced quite some challenges because the biggest portion of my course was computer science undergrads. So their background was, I guess, not the same. So they had never heard about finite element modeling
Yeah.
that goes way above their head. They don't know quadratic programming, which I found out from my colleagues that that's something I couldn't build on. And obviously in computer science we don't teach design, so CAD to them was also unfamiliar. So we had to make certain adaptations and couldn't use the, I guess, advanced models that you have in the labs because it was just going way above their head. But if I had to use it in a graduate course, I think I
Yeah.
could have readily used your labs, but
But
we had to make
yeah,
quite some tweaks.
so
But that didn't end up being a problem because as I said, we taught the course in simulation with simulation before. And so we used our simulation of tendon-driven continuum robots, piecewise constant curvature models from before. And then Emio was just used for some labs. And that was a great thing for the students because they could do coding, which is very natural to them, but then also experience the real robot with some tasks. And so it ended up being a perfect course and the students loved it.
cool, great. And which concept in continuum robotics did Emio help to illustrate?
In this particular course, I think the controller tuning was the ones that the students loved the most.
Okay.
The pick and place was also pretty cool, but I think it was quite limited in what the students were able to do then. And so that was, I think, well, students those days they were bored, I think, pretty easily, whereas I was so excited about it. But yeah, mostly the controller tuning. I wish it was the modeling, but I think students are just struggling with modeling in general. And so that wasn't
They were,
necessarily.
yeah, I think control, you can really interact with the robot and see
Mhm.
the effect of your controller.
Yeah, and also with like any imperfections in the camera. So they for a lot of students, it was just like, oh, there's all these dependencies, and if there's some calibration error, that to them was just really, really, you could see it click in their minds.
So, Jessica, you accepted to be part of the ambassador now program. So you will work on the evolution of Emio. Can you just talk a little bit about it?
hmm Yeah, I plan on continuing to use Emio in my teaching, and as my lab is very much focused on tendon-driven continuum robots, I would like to see a tendon-driven continuum robot on the Emio platform. And there's some ideas we're already discussing, so I think that will be super exciting. And then probably develop a few labs that are more introductory level, so for this undergraduate student cohort so that we can maybe have a little bit of an evolution of more advanced labs for graduate students and simpler entry-level labs for computer science students.
Okay, great. So thank you very much, Jessica, for this testimony, and I'm really happy to have you in our new ambassador program now.
Same here. I love Emmy and I'm happy to support compliance robotics in any way I can.